The next topic in statics is going to be about rigid bodies. And what a rigid body is, let me draw an arbitrary shape. It's usually a typical shape that is shown in statics books. It's like a potato looking thing. So we have this, and what's important about this is that this rigid body has a center of mass, arbitrarily located based on its geometry and how the mass is spread out across the object. So let's say the center of mass is located around here, and then there's points that lie on this body. So let's say this is A and B. So if we define the position vector from A or from the center of mass to B, so RB, and this position vector RA, what we know is that the distances are always constant between A to the center of mass and B to the center of mass. This will always be constant. There's no idea of deformation. But theoretically, every object has some small deformation to them when a load is applied to them. But for the problems that we're going to solve in this video lectures, we're going to assume that that deformation is negligible. So the important thing is that every point on this rigid body is the same distance from each other point from the rigid body. So it could take this point, the distance between this point and B is the same regardless if you rotate it, move it, or anything of that nature. So now that we have this idea of rigid bodies, so I'm going to draw another rigid body over here. And we say that the center of mass is somewhere right here. Then if there's a force being applied across this rigid body, since it has a three-dimensional shape, like let's say F, there's this idea of this object wanting to rotate, assuming that we're rotating if this object has an axis of rotation about its center of mass. So there's this idea of a moment, and we'll discuss that in the future video. But the only reason why a moment exists is because now this object has some length and width that is given to it. Before we were talking about particles which don't have any dimension, so we could ignore moments and torques. But now we have something with width and length. Now we have to consider the idea of moments.